Good evening, Robert Scribbler. It is September 12th, 12:02 a.m. 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I would like to talk to you about a Pacific typhoon which has hit Category 5 status and is barreling off toward a brush with the northern island of the Philippines, and that would be Super Typhoon Mangkhut. I hope I am pronouncing the name correctly. Mangkhut is now a very strong Category 5 typhoon with maximum sustained winds in the range of 160 miles per hour with gusts up to 195 miles per hour. It's moving toward the west, toward the Philippines, and is projected to brush the North Island of the Philippines on the 14th and 15th of September as a very strong Category 5 typhoon. Over the next couple of days, the storm is expected to intensify to 165 or higher maximum sustained winds with gusts of over 200 miles per hour. So a very dangerous situation for the North Island of the Philippines. And downrange, the storm is expected to threaten coastal China as a Category 2 system. So something that has the potential to bring catastrophic impacts to the north coast of the Philippines. I'm going to go ahead and shift over to an Earth null school view and just show you the present position of Mangkhut in this GFS model. And I'm going to go ahead and advance this model for late tomorrow and then late Thursday and into Friday, showing a brush with the northern coast of the Philippines by a very dangerous and powerful tropical cyclone. Now, it's worth noting that we've had a number of destructive storms in this region, one that recently impacted Japan, and I'm just going to show you some of the base conditions that are ongoing. Before I do that, I'd just like to show you that wave heights in this model are showing 17 meters, which is more than 50 feet. Joint Typhoon Warning Center is presently indicating maximum wave heights for this typhoon at 39 feet. So very high waves being produced by this storm. Now, some climate change or climate-related conditions involve very warm sea surface temperatures in the range of 30 degrees Celsius in the path of the super typhoon, and unfortunately warmer waters as the super typhoon approaches the Philippines in the range of 87 degrees Fahrenheit or 30.7 degrees Celsius. So very warm sea surfaces. And looking at the sea surface temperature anomaly map, we find that sea surfaces in this region are warmer than normal in the range of 1 to 1.5 degrees Celsius warmer than normal, helping to increase the peak potential intensity of these storms above typical climatological averages, although a WAG of 1 to 1.5 degrees Celsius is not as significant as the 2 degrees Celsius or more WAG in sea surface temperatures that we see in further northern latitudes that provide the potential for further northern strikes of strong hurricanes. But just pulling back and looking at the Pacific Ocean in general, particularly the western Pacific, is much warmer than normal, and this provides a lot of fuel for hurricanes in the form of both heat rising off of sea surfaces, convective heat, as well as a lot of moisture from evaporation. Both can provide fuel for more intense storms. So it's worth noting that not only on the one side of the world are we looking at Florence potentially impacting the U.S. East Coast in about 36 to 48 hours as a strong Category 4 storm. But we're also seeing a super typhoon now bearing down on the Philippines. So two events that really are not occurring in isolation. The one common denominator being warmer than normal sea surface temperature, providing increased fuel for strong hurricane impacts and typhoon impacts. And this is a fingerprint signature of human-caused climate change driven primarily by fossil fuel burning, which enables the strongest storms to become stronger. Thank you for joining me, and I'll be chatting with you soon.